Okay, I'm back, and now we want to start our tour of the terrestrial planets by talking about the moon. Now, the moon is not a terrestrial planet, but we're going to include it with the terrestrial planets because it is made of rock and it does have a similar history and fate as the terrestrial planets. So, the first thing that you notice about the moon is its size. So it's only going to be about 1/4 the size of the Earth. So to give you an idea, if you imagine that you have your typical Earth globe, which is about this big, and then a tennis ball. So that tennis ball would be about the size of the moon. And then to give you an idea, that if you had a marble that would represent the Earth, and then a P that would represent the moon, and then you put it about 1 meter away from that marble, that would represent about how far away the moon is from the Earth. So in a lot of textbooks, they tend to make pictures that show the Earth and then the moon in orbit around it like that. Well, no. So you need to take this thing and put it about 1 meter away. So the moon really is very far away from the Earth. But the size is going to be the number one thing that is going to determine the fate of the moon. So if we go back to here, and we were talking about the factors that influence the terrestrial planets, and we said mass was one of them. Okay, so the mass is going to affect the fate of the moon. So we'll get back to that in just a few moments. So the rotation and the orbit, the moon orbits the Earth about once every 30 days, and it rotates once every 30 days. And that's the reason why you only see one side of the moon. So you can try this experiment at home, and for it you'll need some kind of a can that has printing on one side, and then what you want to do is you pretend that you're the Earth, and then you're going to hold this thing away from you so that you're always seeing one side of it, okay? And then make it orbit around your body so that, again, you're only looking at one side of it. And notice how many times did this thing rotate as it went around your body, and you're going to find it only does it once. So that this explains why we only see one side of the moon, is that its rotation rate is the same as its orbital rate, and that's as a result of gravity. The atmosphere, okay? What do you think is the thickness of the moon's atmosphere? Do you think it's thick? Do you think it's thin? Or do you think it's the same as the Earth's atmosphere? All right, now remember our flow chart here, so that the moon doesn't have very much gravity because it's so small, so that means it can't really hold on to an atmosphere. So its atmosphere is very, very thin. It's something like 1/1,000,000th of the atmosphere of the Earth. So for all intents and purposes, we say that the moon is airless, but it really does have an atmosphere. It's just incredibly thin. So what does that tell you about the pressure of the moon, of the atmosphere on the moon? Think about dominoes. So the thicker the atmosphere, the greater the pressure. So if it has a thin atmosphere, then that must mean it has very little air pressure. Okay, then what does that tell you about its oceans? So does the moon have oceans of liquid water like the Earth does? No, because it doesn't have enough air pressure to keep the liquid water liquid. It's all evaporated. And we don't think that the moon ever had any liquid water on it, even when it first formed. Okay, then temperature. So the temperature on the moon varies between negative 130 degrees Celsius to positive 120 degrees Celsius, or in terms of Fahrenheit, negative 208 to 250 degrees Fahrenheit. So that's incredibly cold and incredibly hot. So on the one hand, it gets very cold on the moon, and on the other hand, it gets very hot on the moon. So what's the difference? Okay, it's got the thin atmosphere, and if we look at our flow chart, what did the atmosphere do? The atmosphere moderates the climate, or it helps to moderate the climate. So that, think about like if you were in the middle of a desert, okay, and there's no clouds. During the daytime, it's incredibly hot. But then at night, if there's no clouds, it gets incredibly cold because all of that heat just escapes into outer space. So the thicker the atmosphere, that's going to help to moderate the climate so that you don't have the swings between the daytime temperatures and the nighttime temperatures. So if you are in the sun on the moon, it's going to be 120 degrees Celsius. If you are in the shade on the moon, it's going to be negative 130 degrees Celsius. And it's all because it has that very, very thin atmosphere. Okay, let's talk about the geology of the moon. So the composition, igneous rocks. So stuff, it's going to have things that is very similar to basalt is going to be the main kind of rock that is on the surface of the moon. It also has another kind of igneous rock called anorthosite, which is yet another igneous kind of rock. So that gives us a clue as to the origin of the moon. Very volcanic, very primitive. So you're not going to find any sedimentary rocks on the moon because there's just not going to be any wind or rain that could erode those igneous rocks and turn them into a sedimentary rock. Now you do have erosion though that powders the rock. So if you look at the people that came back from the moon on their spacesuits, they had a lot of dust, so that the impacts of all those meteorites on the surface of the moon, it has powdered those igneous rocks so that there's different kinds of minerals and stuff there, but it hasn't been cemented back together again to turn into a sedimentary rock. The picture there, the picture on the left shows you that the moon does have a core, but it's going to be much smaller than the core of the Earth, and really the moon is pretty much solidified. So there are some places inside the moon that are still hot and they're kind of mushy, but nothing like liquid that is going around and around like inside the Earth. The picture that is to the right shows you the surface topography. So that blue area is going to represent areas that are topographically lower, and then the yellow and green areas show the areas where you'd have mountains. So the areas that are topographically high on the surface of the moon. Plate tectonics. So do you expect that the moon is going to have volcanoes and areas where the plates are being pulled apart and areas where the plates are being pushed together and areas where the plates are sliding past each other? No. It cooled off very rapidly, and when it did that, it lost its ability to have plate tectonics. Now, it still has earthquakes. Well, we don't call them earthquakes, they would be moonquakes. So occasionally things do kind of jiggle inside the moon, and then that generates moonquakes, but nothing of any major significance. Okay, then the last thing I want to mention about the moon is going to be the Maria and the Highlands. So the Maria is going to be the dark areas of the moon, which it's going to be the dark gray on the left-hand side, and on the right-hand side, that's going to be the bluish areas. And then you got the lunar highlands, which is going to be the kind of like the white part of the moon, and on the left hand, and then on the right hand, it's going to be the yellows and the greens parts. So it's kind of hard to see those pictures, so you can always blow them up so that you can look at the pictures in more detail. And what I want you to see is the white areas, the lunar highlands, have a lot more craters on them than what the blue parts do, the Marias. So Galileo called them Marias because he thought that they were oceans. And Maria is an Italian word for ocean. So this gives us a clue as to what caused the Maria. Because if you look at the Maria, you'll notice that they make circles. So look closely at those blue parts, and you'll notice that they make circles. And so what those are is they're actually craters. And so what would happen is that an asteroid would come in and it would hit the surface of the moon so hard that it would go through the crust and into the mantle area underneath it. And then that would heat up the mantle enough to where lava, magma, would come up and then would fill in the crater. So then that's the reason why you see the Maria. So they're filled in craters with a darker material that came from the mantle of the moon. So I think that that's all I want to say about the moon, and then later we will talk about the origin of the moon. So next we're going to go out to Mercury in our next segment. So I'll see you then.